Hey everyone, today we're going to master one of the most recognizable shapes in all of algebra, the square root function. I'm sure you've seen it. It's that curve that kind of looks like an eyebrow, right? Well, we're going to learn how to draw it, move it, and even stretch it, all with a simple method I like to call build a graph. Let's jump right in.
So there it is. The big question is, what actually defines this shape? And more importantly, how can we pick it up and move it anywhere we want on a graph? Well, today we are building the exact blueprint to do just that. You're going to have total control over this curve. Okay, but before we can start shifting things around, we have to understand the original model. You know, every complex building starts with a solid foundation, and for us, that foundation is the basic, untouched square root graph.
And here it is, our parent function, f of x equals the square root of x. Think of this as the graph's original DNA. It has a very specific starting point, right at the origin, 0, 0. Its domain, all its possible x values, kicks off at 0 and just goes on forever. And its range, the y values, it does the exact same thing. This is our ground zero.
All right, so our foundation is solid. Now for the really fun part, the blueprint. There's actually a master formula that acts like a set of instructions for taking that original eyebrow and transforming it into literally any other square root graph you'll ever see.
And this is it. This is the master formula. Each of these letters, A, H, and K, is like a control knob, and each one has a very specific job. H is going to control our side-to-side movement, K handles the up and down, and A takes care of stretching and even flipping the graph. Let's break down what each one does.
First up, we've got H, our horizontal shifter. This is the value that's tucked inside the square root, right there with the x. Now here is the one tricky part you absolutely have to remember. It works in reverse. If you see x minus 2, your brain screams move left, but no, you actually move to the right. It's always the opposite of the sign.
Next up is K, the vertical shift. And the good news? This one is totally straightforward. It's just the number hanging out at the very end, outside of the square root. If K is positive, the graph goes up. If it's negative, the graph goes down. Simple. What you see is what you get.
And finally, we have A, which is kind of like the director of the graph's shape. This value is a triple threat. First, if A is negative, it flips the entire graph upside down. You get an upside-down eyebrow. Second, if its absolute value is bigger than 1, it stretches the graph vertically, making it look much steeper. And third, if it's a fraction smaller than 1, it squishes or compresses the graph, making it look a whole lot flatter.
Now, after looking at all those individual controls, here's the secret that ties it all together. This is the most powerful shortcut you have. The H and K values literally give you the exact coordinates of the new starting point for your graph. You just pull them right from the equation and boom, you know precisely where your new eyebrow begins.
Okay, we've got the blueprint, we know what all the control knobs do, and we have our secret shortcut. Let's head to the construction zone and put this into action with a couple of really clear examples.
Let's start with this one. Y equals the square root of x minus 2 plus 3. First thing we do is identify our H and K. Inside, we see x minus 2, so our H is positive 2. Remember, opposite. Outside, we have a plus 3, so our K is just 3. That means our new starting point is exactly 2, 3. From that point, we just sketch our basic eyebrow shape. And hey, notice how the domain now starts at our H value of 2 and the range starts at our K value of 3? It all lines up.
Okay, one more, but this one's got a twist. See that negative sign out front? That tells us A is negative 1, which means it's a reflection. Inside, we have x plus 1, so remember that opposite rule. Our H value is negative 1. Our K is 4, so that puts our starting point at negative 1, 4. And from there, we just draw our eyebrow reflected opening downwards. This also flips the range, which now goes from negative infinity all the way up to our K value of 4.
This chart really shows you the power of that A value. When A is just 1, we get our normal curve. But when A is 2, look at that. The graph gets stretched vertically and shoots up way faster. And when A is a fraction like 1/2, it gets compressed, squished down, and looks a lot flatter. It's the same starting point, but a completely different journey from there.
All right, our construction skills are looking pretty sharp, but you know, every good builder does a quality control check. So let's look at the 2 most common mistakes people make so that you can avoid them completely.
This right here, this is the #1 trap, the horizontal shift sign. I'm telling you, your eyes see x minus 2 inside that square root, and every single instinct you have is going to scream, move left. You have to fight that instinct. The rule is absolute. The sine's effect is the opposite. -2 means you move right 2. Please burn that into your memory.
So let's put this on our final checklist. First, always, always, always remember the opposite rule for horizontal shifts. And second, don't forget that as the graph moves, its domain moves right along with it. Your new domain is always going to start at whatever your h value is. So, we've totally mastered this abstract eyebrow graph. But why should you care? Well, it turns out this specific shape shows up all over the real world, and it models a really important concept.
This curve is the perfect visual model for an idea called diminishing returns. It's this concept that when you start something new, your initial effort produces these huge results. But as you keep going, each little bit of extra effort produces less and less of a gain. The curve starts off steep, and then it just flattens out.
And here's the perfect analogy for it. Think about studying for a big test. That first hour, man, your score might jump 20 points. The next couple hours might add another 10. But that 10th hour you spend studying, it might only give you 1 extra point. That is diminishing returns, and it has the exact shape of a square root graph.
So I'll leave you with this question. Now that you can recognize this pattern, this rapid initial growth that's followed by a leveling off, where else do you see it? Think about learning an instrument, or a new business growing, or even your own progress at the gym. The eyebrow curve is literally everywhere. Once you know how to look for it,